So good morning everyone. Hope you enjoyed your holidays. Enjoyed or not? Enjoyed, right? Yes. So today we are going to study about trigonometry. Introduction to trigonometry. A very interesting chapter and important chapter. What is trigonometry? Anybody please turn on the fan. What is trigonometry? In Greek, tri means what? Three. Gono means sides, not angles. Metry means measurement. Then what is trigonometry? What is trigonometry? Trigonometry is a branch of mathematics which deals with study of relationship between sides and angles of a triangle. Trigonometry is a branch of mathematics which deals with the study of relationship between sides and angles of a triangle. Is called trigonometry. Trigonometry is very simple. Most of your seniors telling that trigonometry is like very difficult subject in mathematics. I know even after completing the PUC also, you can go and ask science students, those who have completed PU science. Trigonometry is useless. Why we have to study trigonometry? It's very difficult subject. If trigonometry is not there, means mathematics out of out. Because of trigonometry, I lost many marks. And weightage on this chapter, 5 marks. Minimum 4, maximum 5 marks. One MCQ question, 1 mark on MCQ question, and 2 mark on short answer type question. Either 2 mark or 3 mark. Sometimes 3 mark short answer type. 1 mark on MCQ, 2 mark short answer type, 3 mark also short answer type. So total weightage 5 marks. Minimum 4, maximum 5 marks. Okay? Yes. So why we have to study trigonometry? Any idea? What are the applications of trigonometry? One more chapter is there next. Applications of trigonometry. In that chapter, I will tell you detail why we have to study trigonometry. But basically, I am asking you any idea why we have to study trigonometry? Why we want to study trigonometry? Yes? You know, mathematical basic operations like addition, subtraction, multiplication, and division. Why do we need to study these all things? Basic mathematical operations. Yes? Why we need to study? Any one application you can tell? No idea. Why do we need to study addition? In our daily life? It is required. How it is required? And why it is required? So similarly, you know, every day we are using addition, every day we are using subtraction, multiplication, division, and mathematics is like our real life it is. How you know? So one of the mathematicians said, mathematics and human life both are simultaneously each other. How it is? How they relate mathematics to our human life? You can add your friends in your life. You can subtract your enemies in your life. You can multiply your happiness. You can divide your sorrow. So this is what the mathematics is. Okay. So similarly, why we need to study trigonometry? Any idea? What are the uses of trigonometry? You know, you have studied astrophysics. Astrophysics, in astrophysics, planets have studied, moon you have studied. So the distance, calculating distance between moon and sun, calculating the distance between earth and planet, they're all we are using the trigonometry. Without trigonometry there is no physics. Not now in PUC. Then how to build the tower? How to calculate the distance between 2 mountains? How to calculate the depth of the ocean? In all these cases we are using trigonometry. Calculating the distance of 2 towers, calculating the heights of the buildings, calculating the distance between 2 mountains, calculating the depth of the oceans. Here all we are using trigonometry. Trigonometry is very simple. Write the definition first. Take the definition. Right siding definition. Then heading trigonometry and total weightage 5 marks. Weightage 5 marks. Right definition. Trigonometry is a Greek word. Trigonometry is a Greek word. Trigonometry is a Greek word. Is divided into 3 parts: tri, gono, and metry. Tri, gono, and metry. Tri, gono, and metry. Okay. So next you can write tri means 3, gono means sides, metry means measurement. Tri, gono means sides and metry means measurement. Metry means measurement. Okay. Yes. Or, write the definition now. O or R. One more definition. Trigonometry is a branch of mathematics. Trigonometry is a branch of mathematics. Trigonometry is a branch of mathematics which deals with study of relationship between sides and angles of a triangle. Which deals with study of relationship between sides and angles of a triangle. Let me repeat again. Trigonometry is a branch of mathematics which deals with the study of relationship between sides and angles of a triangle. Okay? Yes. See, this whole trigonometry depends upon right angles. Whole trigonometry only depends upon right angle triangles. Right angle triangle. You know right angle triangle. What is the right angle triangle? A triangle in which any one angle which measures exactly 90 degrees is called a right angle triangle. Am I right? Yes. Here ABC is a right angle triangle. ABC is a right angle triangle and angle B is 90 degree. Angle B is 90 degree. Here the angle forming at C in this triangle, angle forming at C, that we can call it as a theta. That we can call it as a theta. So the spelling is Theta, theta, but pronouncing is theta. Okay. So here angle formed at C, in this triangle, angle formed at C. Then this BC is called base. BC is called base. And this AB is opposite to this theta. AB is opposite to theta. So this is the opposite side. And this AC is the hypotenuse side. So AC is a hypotenuse. And BC is a base. Or you can call it as a adjacent. And this AB is opposite side. So after this, a Pythagoras theorem. That is also very important. Pythagoras theorem. Can anyone state Pythagoras theorem? Yes, Pythagoras theorem. Anybody? Mallikarjun? Sit and tell.
The square of hypotenuse is equal to sum of squares of other two sides.
In a right angle triangle. First, in a right angle triangle, a square of hypotenuse is equal to the sum of squares of other two sides. So that is nothing but AC square is equal to AB square plus BC square is what? Pythagoras theorem. Right side reading Pythagoras theorem. Pythagoras theorem, write the statement. In a right angle triangle, a square of hypotenuse is equal to sum of squares of other two sides. A square of hypotenuse is equal to sum of squares of other two sides. Sum of squares of other two sides. Okay? Yeah, draw this triangle. Draw triangle ABC. And angle formed at C is theta. This is the opposite side. AB is the opposite side. And BC is the base, or you can call it as the adjacent side. And AC is the hypotenuse side. Let's finish. Run fast. Then later you can write AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. And the representation of angle theta, here you can write theta. If you are not understanding, theta. The next, basic trigonometric functions. How many are there? Basic trigonometric functions. Right side in basic trigonometric functions. How many are there? Six are there, correct? So there are 6 basic trigonometric functions. Among them, the first one is sine theta. S-I-N-E, sine theta, sine theta. Cosine theta, cosine theta. Tangent theta, tangent theta. Next, cotangent theta, cotangent theta. Next, cosecant theta, cosecant theta. Secant theta. So in circles we have studied tangent and secant. In 9th standard we have studied tangent. In 9th standard we have studied secant. What is tangent? Recall 9th standard chapter. Tangent. What is tangent? A line drawn out of the circle. Here is one circle. And I am drawing one line out of the circle. Is AB is a tangent? A line
which drawn from the circle which meets at only at one point.
Yes, no. A line. See, it's a circle here. Here I am drawing a line. AB is a tangent here. AB is a tangent. So what is the definition? A line which intersects a circle at a single point. A line which intersect or touches a circle at a single point is called what? Tangent. Then what is secant? Any idea? Sahana? Secant. Two lines which drawn in the circle. A line which intersect the circle at 2 points. Here BC is a secant. BC is a secant and AB is a tangent. Understood? Yes. So we are talking about the basic trigonometric functions. The first one is sine theta. Next, cosine theta, tangent theta, cotangent theta, cosecant theta, and secant theta. So in short, this sine theta you can write it as sine, S-I-N-E. Sin you can write it as sin, sin. Cosine, cos, cos, cos. Tangent, tan. Cotangent, cot. Cosecant, cosec, cosec theta. Then secant, sec theta. Sine, in short, we can write it as sin, sin theta. Cosine, cos theta. Tangent, tan theta. Cotangent, cot theta. Cosecant, cosec theta. Secant, sec theta. Okay, yes, right. Right side heading, basic trigonometric functions. There are 6 basic trigonometric functions. There are 6 basic trigonometric functions. There are 6 basic trigonometric functions. Among them, note on this: first one, second one, third one, fourth one, fifth one, and sixth one. Dismiss. Note on first. Now, right side heading, trigonometric ratios. These are the 6 basic trigonometric functions. Now, trigonometric ratios. Trigonometric ratios. See, as I told you, the whole trigonometry depends upon only right angle triangle. So first, let me draw now one right angle triangle. ABC is a one right angle triangle. ABC is a right angle triangle. Right angled at B. Right angled at B. Triangle B is angle. Imagine angle forming at C. Angle forming at C. If angle forming at C, BC become base adjacent. BC become base adjacent. And AC hypotenuse. In a triangle, which is the longest side? Hypotenuse is the longest side. Okay. And AB opposite. Height is nothing but what? Opposite side. One more triangle I have to draw here. The triangle is XYZ. One more triangle, XYZ. And here, right angle at Y. Right angle at Y. And angle formed at X. Angle formed at X. Here angle formed at C. But here angle formed at X. At the top. Okay. So can you tell me which side is the opposite side and which side is adjacent side and which side is adjacent? Sorry, hypotenuse side. Hypotenuse will not change. Hypotenuse remains same. So this is the hypotenuse side. Then which side is opposite side? YZ is the opposite side. And which side is adjacent side? XY is the adjacent side. Hope this one is clear. Any doubts? Any doubts here? No. Yes, now we can take the trigonometric ratios. So already we know that there are 6 trigonometric basic functions. The first one is sin theta, SIN. Sin theta. Sin theta we can define it as opposite upon hypotenuse. Sin theta we can define it as opposite. Here is opposite. Opposite upon hypotenuse is equal to AB upon AC. AB upon AC. Here also same. Sin theta is equal to opposite upon hypotenuse. So this side is opposite, that is YZ upon XZ. So now cos theta. Cos theta is equal to yes adjacent upon hypotenuse. Cos theta is adjacent base upon hypotenuse. So that is adjacent upon hypotenuse is equal to BC upon AC. Tan theta. Tan theta is equal to opposite upon adjacent. Opposite upon adjacent. We are not taking a hypotenuse here. Opposite upon adjacent. So opposite upon adjacent is equal to AB upon BC. These are the main trigonometric functions. Sin, cos, tan. The remaining three are there, no? They are co-trigonometric functions. Why they are co? Reciprocal of sin is cosec. Reciprocal of cos is sec. Reciprocal of tan is cot. See. Now cosec theta is equal to just reciprocal this. Hypotenuse upon opposite is equal to AC upon AB. Similarly, sec theta is equal to, I just reciprocal this. Numerator become denominator and denominator become numerator. So hypotenuse upon adjacent. Hypotenuse upon adjacent is equal to AC upon BC. AC upon BC. So similarly, tan. Reciprocal of tan is cot. Reciprocal of tan is cot. So cot theta is equal to adjacent upon opposite. So is equal to BC upon AB. BC upon AB. So these are the trigonometric ratios. Understood? Note. Is finished? Okay. Now, right side some important relations. Some important relations. So, do you have any doubts here? Any queries? Some important relations. Okay. Sin theta is a reciprocal of, yes, cosec theta. Sin theta is a reciprocal of cosec theta. Similarly, cosec theta is a reciprocal of sin theta. Correct? Not sec. Okay. Cosec theta is a reciprocal of sin theta. Vice versa. So now cos theta is a reciprocal of sec theta, and sec theta is a reciprocal of cos theta. Tan theta is a reciprocal of cot theta, and cot theta is a reciprocal of tan theta. Correct? And tan theta, how can we express in the form of sin and cos? Tan we can express as sin theta upon cos theta. Based on the ratios I am writing, you can see the ratios there. Sin theta is equal to opposite upon hypotenuse. Cos theta is equal to adjacent upon hypotenuse. If you divide sin and cos, means sin theta upon cos theta, what you will get? Opposite upon hypotenuse whole divided by adjacent upon hypotenuse. So their hypotenuse will get cancel each other. Only opposite upon adjacent. Opposite upon adjacent is nothing but what? Tan theta. So that is tan theta is expressed in the form of sin and cos. How can we express sin theta upon cos theta? So similarly, cot theta also we can express. Already we know cot is reciprocal of tan. Tan theta is sin theta upon cos theta. So cot theta is cos theta upon sin theta. Cos theta upon sin theta. Yeah, note of this. Some important relations. Note down. And this chapter we can write in geometry book. Okay? Is finished? Yeah. Any doubts here? Boys, any doubts last? No doubts? Okay. In this chapter only three concepts are there. First one is introduction to trigonometry. Then second one, trigonometric functions. Then the third one, trigonometric ratios. That's it. So now, can we take exercise? Yeah, first exercise. Exercise number 8.1. 8.1. In triangle ABC, right angled at B. AB is equal to 24 centimeter, BC is equal to 7 centimeter. Determine sin A, cos A. Second one, sin C, cos C. See, here is our triangle, and the triangle is ABC. ABC, right angled at B. ABC, right angled at B. AB, they have shown AB is 24 centimeter. AB is 24 centimeter and BC is 7 centimeter. Determine sine A. First one, we'll write here sine A, comma cos A, and second one sine C, comma cos C. It means that the first time angle formed at A here, the angle formed at A, and second time, in second example, the angle formed at C. Sin A you know very well. How to define sin A? Sin A is equal to opposite upon, these ratios are very important. You have to add these ratios. Sin A is equal to, means sin theta is equal to opposite upon. And one more thing, most of the students thought that sin theta, sin A, sin C, here this sin theta, sin A, sin C, these are not the multiplications, these are not the products. These are not the products. Sin is a function, theta, A, C is an angle. If you are only writing sin, it doesn't give any meaning. If you write the function along with the angle, then only it will give us some meanings. Are you getting me? And don't think that sin theta means sin and theta are the products, multiplication. No, not like that. Okay? Yes, now coming to the point, sin A. Sin A, how can we define? Opposite upon hypotenuse. In this triangle, angle formed at A. Imagine angle formed at A, and this is a adjacent side, not hypotenuse. This is a opposite side, and this is a hypotenuse. How you define sin? Sin is equal to opposite upon hypotenuse. Correct? But hypotenuse is not there. We need to calculate hypotenuse. How can we calculate? Yes, using Pythagoras theorem. Right here, in a triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. Then we can apply Pythagoras theorem. Pythagoras said that in any right angle triangle, a square of hypotenuse is equal to sum of squares of other two sides. That is, AC square is equal to AB square plus BC square. What is AB? Given in the question, 24 square plus BC 7 square. Square of 24, 576. Don't know. Square of 7, 49. 576 plus 49, 625. So AC square is equal to 625. AC is equal to under root 625. So AC is equal to 25 plus or minus. But here we are considering only positive values because it's a distance, length. So AC is 25 centimeter. Now we can calculate the first one and second one. First one, sin A is equal to opposite upon hypotenuse. Sin A is equal to opposite upon hypotenuse. A means here, angle formed at A. Opposite is hypotenuse is, so 7 upon 25. Second one, cos A. Cos A is equal to adjacent. This is adjacent. Adjacent upon hypotenuse, 24 upon. Just we can write here, adjacent upon hypotenuse is equal to 24 upon 25. So now second one sin C. So now angle shifted from A to C. Angle shifted from A to C here. Angle formed at C. Sin C. Opposite upon hypotenuse. Okay. Sin C is equal to opposite upon hypotenuse is equal to 24 upon 25. Next, cos C. Cos C is equal to adjacent upon hypotenuse, 7 upon 25. Cos C is equal to adjacent upon hypotenuse is equal to 7 upon 25. Understood? Any doubts? Do not hesitate to ask the doubts. If you have any doubts, you can ask me now itself. Then later don't tell that trigonometry is a difficult chapter. Yes, finish. Yes, can take the second example. Example number 2. In figure 8.13, example number 2. In figure 8.13, find tan P minus cot R. And trigonometric functions always in a small letters, not in the capital letters. Few of the student writing first letter capital. We are very good in English, sir don't know English, so that's what we are writing first letter in English. No, always you have to write in a small letters. Understood? So tan P minus cot R. So figure is given here. P Q R. PQ is 12 centimeter and PR is 13 centimeter. Right angled at Q. Right angled at Q. How to define tan? Opposite upon adjacent, right? Opposite upon adjacent. But adjacent is not given. QR is not there. Again Pythagoras theorem. With the help of Pythagoras theorem, we can calculate the base of the triangle. So in a triangle PQR, right angled at Q is equal to 90 degree. Angle Q is 90 degree. A square of hypotenuse is equal to sum of squares of other two sides. PR square is equal to PQ square plus QR square. PQ square plus QR square. PQ is given in the question. That is 12. So 12 square is equal to 13. PR is given, right? PR is 13 square. Square of 13 is equal to PQ is square of 12 plus QR. Don't know it as it is square of QR. Square of 13 is 169. And this 12 square I can take left hand side, it become negative. So 144 is equal to QR square. 169 minus 144 is 25. Correct? 9 minus 4 5, 6 minus 4 2, 25. Square of QR. So QR is equal to under root 25 is nothing but 5 centimeter. QR is 5 centimeter. So now I can write the side of a triangle PQR, that is QR 5 centimeter. Tan P minus cot R. Tan P minus cot R. Tan P minus cot R. See, tan angle is P and cot angle is R. Tan P is here. How to define tan? Opposite upon. So this is opposite, this is a adjacent. QR minus PQ. Cot R. Huh? Adjacent upon opposite. Same QR upon PQ. See, QR minus PQ, QR minus PQ cancel. 0. No need to calculate this one. Understand? It's not. Yes, can you take next example? Yes, third one. If sin A is equal to 3 upon 4, third one, if sin A is equal to 3 upon 4, sin A is equal to 3 upon 4. Calculate cos A and tan A. Calculate cos A and tan A. Yeah, see here. Stop writing. See here. So sin A is given. Sin A is equal to 3 upon 4 and asked to calculate cos A and tan A. So let me draw a triangle ABC. A, B, C. Right angle at B. Right angle at B. And angle formed, theta formed at A. Angle formed at A. So what is given? Sin is given. Sin A is equal to 3 upon 4. How to define sin? Sin is opposite upon hypotenuse. So here is opposite, right? Opposite upon hypotenuse. And asked to calculate cos A and tan A. How to define cos? Cos A is equal to adjacent upon hypotenuse, but adjacent is not there. Again, with the help of Pythagoras theorem, we can calculate one more side of the triangle. In a triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. Sum of squares of other two sides is equal to a hypotenuse square. So AC square is equal to AB square plus BC square. AC is given, that is 4. The square of 4 is equal to AB, don't know, write as it is. AB square plus BC is also given, that is a square of 3. So now 4 square is 16. This 3 I can take left hand side. 16 minus 9 is equal to square of AB. 16 minus 9? So AB square is equal to 7. 9 plus 7 is 16. Correct? And 16 minus 9 is 7. So AB is equal to under root 7. AB is equal to under root 7. So now they ask to calculate cos A and tan A. So cos A is equal to, how to define cos? Adjacent upon hypotenuse. Cos A is equal to adjacent upon hypotenuse. And angle formed at A. Here, angle formed at A. So this side is a base, adjacent, and hypotenuse same, it will not change. Okay. So adjacent is AB divided by hypotenuse is AC. So adjacent AB is root 7 upon hypotenuse is 4. And next, ask to calculate tan A. So tan is equal to opposite upon adjacent. Opposite upon adjacent. So opposite is 3 and adjacent is root 7. So 3 upon root 7. Check in answer sheet. Am I right? Huh? It's not done. How many girls did attend class today? Three. Class A 2. Class A 3. Now other classes, class B and class A. Okay. Class B. Huh? One who? What's the name? Rika. First one I am hearing the name. And what about boys? Those who will not attend the class, I will not give it, you must keep in your mind. Yes, sir. Do you have any doubts here? Note on first. You can take next example. Question number 4. Stop writing, look at the board. Question number 4. Given 15 cot A is equal to 8. Find sin A and sec A. Sin A and sec A. Yes. 15 cot A is equal to 8 and asked to calculate sin A and sec A. Solution. What is given? Write the given data. What is given? Given that 15 cot A is equal to 8. It's a given data. So cot A is equal to 8 upon 15. Correct? So now you can draw the triangle A, B, C. Right angle at B. Right angle at B. I am usually taking this vertex as a A and this vertex as a C. Because it's easy for me. Okay? I will not get confused. So I am usually taking this as a A. Because here it's mentioned that cot A sin A sec A. Yeah? So angle formed at A. Theta formed at A. How you define cot? Cot is equal to adjacent upon opposite. Tan is opposite upon adjacent and cot is reciprocal of tan, that is adjacent upon opposite. So adjacent upon opposite. Adjacent upon opposite. But ask to calculate sin A. How you define sin? Sin is equal to opposite upon hypotenuse. But hypotenuse is not there. Correct? So we need to calculate hypotenuse using Pythagoras theorem. So in a triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. So now AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. AC square don't know, right, as it is. AC square is equal to AB is given, that is 8 square. And BC is also given, that is square of 15. Square of 15. 8 square is 64 and square of 15 225. So 225 plus 64. 5 plus 4 9. 6 plus 2 8 and 289. AC square is equal to 289 and AC is equal to under root 289. So AC is equal to 17. 17 square is 289. So AC is equal to 17 centimeter. Now you can write sin and sec. Sin A is equal to opposite upon hypotenuse. So hypotenuse is 17. 15 upon 17. And next is sec A. Sec is reciprocal of cos. How to define cos? Adjacent upon hypotenuse. Sec, hypotenuse upon adjacent. Hypotenuse upon adjacent. That is 17 upon 8. Check in answer sheet. Sin A is 15 upon 17 and sec is 17 upon 8. Am I right? Let's note down first. Is finished? Okay. So next example we can take. Question number 5. Fifth question. Given sec theta is equal to 13 upon 12. 13 upon 12. Calculate all other trigonometric functions is the question. Okay. So only given that sec theta. Sec they have given means one more function easily you can get. Which function? Cos. So cos theta is equal to 12 upon 13. Solution. Given that sec theta is equal to 13 upon 12. 13 upon 12. So let me draw one triangle A, B, C, right angle at B, and angle formed at A theta. Angle formed at A theta. You know how you define cos. How to define cos? Cos theta is equal to adjacent upon hypotenuse. So sec theta is hypotenuse upon adjacent. Hypotenuse upon adjacent. Cos is adjacent upon hypotenuse. Sec is hypotenuse upon adjacent. So one more side we can calculate, that is BC. In a triangle ABC, again Pythagoras theorem. In a triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. A square of hypotenuse is equal to sum of squares of other two sides. AC square is equal to AB square plus BC square. So AC is square of 13, AB is square of 12, and BC don't know. 13 square 169 minus 124. This 12 I can take left hand side. Is equal to square of BC. 169 minus 144 is 25 is equal to BC square. So BC is equal to 5. BC is equal to 5 centimeter. BC is equal to 5 centimeter. So here it is 5. So now you can write other trigonometric functions. First one is sin theta. Sin theta is equal to opposite upon hypotenuse. 5 upon 13. And cos theta adjacent upon hypotenuse. 12 upon 13. Only two functions enough. With the help of two functions, we can write all the functions. How? See, sin is 5 upon 13, cos is 12 upon 13. And in important relations, I have given you that tan theta is equal to sin theta upon cos theta. So tan theta is equal to 5 upon 12. And sin is a reciprocal of cosec. Cosec theta is equal to 13 upon 5. And sec theta given. Sec theta is equal to 13 upon 12. And tan is the reciprocal of cot. Cot theta is equal to 12 upon 5. Note. क्लास फोन पदे पदे Is any doubts here? Note down first. Okay, can we take next example? Note down fast. Is it other writing? Huh? Show me. This example you can show. Is that right angle triangle? Huh? Yes. Right. I told you many times, if you are not interested, do not come to school. Better off to see some other jobs and all. Simply do not waste your parents' money and your time also. Just finished? Okay, next example. Example number 6, right? Yeah. If angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B is the question. See here, question number 6. If A and B are acute angles, imagine here is one triangle. Triangle is ABC. A, B, sorry, B is acute angle. A, B, C. C is the right angle and B is the acute angle. A and B are acute angles. See, angle sum property of triangles you know very well. So what is the angle sum property of a triangle? 180 degree. If angle C measures 90 degree, what about other two angles? If angle C measures 90 degree, what about other two angles? Sum of other two angles also 90 degree. According to this question, I can say that angle C is 90 degree and sum of angle A plus angle B 90 degree. Can I write like this? Yes or no? Yes. So what they say? A and B are acute angles such that cos A is equal to cos B. Cos A is equal to cos B. Cos A is equal to cos B. So how you define cos A? Huh? Sorry? Adjacent upon hypotenuse. Cos A is equal to here cos A, adjacent is here and hypotenuse here. BC upon AB. And cos B? No. Adjacent upon hypotenuse. AB, not AC. AC is opposite. Cos A, angle formed is here, theta formed is here. So theta formed is here, right? Theta formed is here. This is adjacent. AC and this is opposite AB. So cos B, now cos B. BC upon BC. BC upon AB. BC upon AB. AB cancel. AB cancel. AC is equal to BC. AC is where? This one. AC. Correct? And BC is here. AC is opposite of which angle? AC is opposite side of which angle? Angle B, right? And BC is opposite side of which angle? Angle A. Again recall Man's-Hand theorem. Angles opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle are equal. Sides opposite to equal angles of a triangle are equal. Understood? Huh? Simple. This one is not required. Just for your understanding, your reference, I wrote this. Okay? Note down. And reason. First time should you can write the reason here. Here reason you can write. Angle A is equal to angle B. because angles opposite to equal sides of a triangle are equal. Equal sides of a triangle are equal. If you will not write this reason, then you will not get the marks. So reason is compulsory. Hence the proof. Note down. Complementary angle definition is different, man. What are complementary angles? One of the student asked here, if angle plus A plus angle B is equal to 90 degree, then why they didn't become the complementary angles? Then why they are acute angles? He is asking me. So actually, what is the definition of complementary angles? Here one angle is there, angle 30 degree, and here one angle 60 degree. Can you say that these two angles are complementary? Can you say these two angles are complementary? No. Here one angle ABC and then one angle ABD. Sum of these two angles 90 degree. These two angles are complementary. Complementary angles have the common vertex and one common arc. Common vertex and common arc. Hope you are satisfied with my answer. Yes, no. Is finished? Yeah. So can we take next example? 7th one now. Question number 7. If cot theta is equal to 7 upon 8, evaluate 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta, and second one cot square theta. Okay? Yes. So important example, 2 mark example, it is important. Let's move. Cot theta is equal to 7 upon 8. Cot theta is equal to 7 upon 8. It's a given data. And asked to calculate first one 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. First one. And second one cot square theta. Second one cot square theta. Okay? Yeah. See, cot theta is equal to 7 upon 8. Let me draw a triangle A, B, C. Theta formed at A. Theta formed at A. How you define cot? Cot is equal to adjacent upon opposite, not hypotenuse. Adjacent upon opposite. Adjacent upon opposite. Okay. So now sine function we have to write and cos function we have to write. If you want to write the sine function, hypotenuse side is required. Am I right? How you define sine? Sine theta is equal to opposite upon hypotenuse and cos theta is equal to adjacent upon hypotenuse. Correct? Yes. Again Pythagoras theorem you can take. In the beginning only I told you, this whole trigonometry is depend upon right angle triangle and Pythagoras theorem. In a right angle triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. Again, a square of hypotenuse is equal to sum of squares of other two sides. That is AC square is equal to AB square plus BC square. Correct? So AB 7 square and BC is 8 square. 7 square is 49 and 8 square is 64. 9 plus 4 13, 60 plus 40 100. 113. AC square is equal to 130. Correct? So AC is equal to under root 130. No need to split this one, right, as it is no problem. So now asked to calculate 1 plus sin theta, first one 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. Okay, so sin theta we can write down. Sin theta, sin theta is equal to opposite upon hypotenuse. Hypotenuse just now we calculated, that is 100 and root 30. Opposite upon hypotenuse, 8 upon 100 and root 13 sin theta, and cos theta adjacent upon hypotenuse, that is 7 upon 100 and root 13. Am I right? So now 1 plus sin and cos value we can substitute here. 8 upon 100 and root 13 into 1 minus 8 upon 100 and root 13 divided by 1 plus cos theta 7 upon 100 and root 13. 7 upon 100 and root 13. Similarly 1 minus 7 upon 100 and root 13. See, you can see the numerator and see the denominator. It looks like a plus b into a minus b, right? See, a plus b into a minus b, a plus b into a minus b. So what is the expansion of a square minus b square? Identity, algebraic identities. A square minus b square is equal to a plus b into a minus b. So now we can write this as a square minus b square. 100 and root 13 square. Make it complete. So now denominator is the same. 1 square minus 7 upon 100 and root 13 whole square. Am I right? Any doubts here? Any doubts? No. Yes. Next step. 1 square 1. 8 square. This square related to both numerator as well as denominator. Not only a numerator. 8 square. 64 upon 100 and root 13 square. Square root get cancelled. So 113 divided by 1 square 1 minus 7 square 49 divided by 113 square. Under root 113 square. Square root get cancelled. Again it is 130. See, in numerator denominators, 1 and 113 are the denominators. In numerator, 113 and 1 are the denominators. So LCM is 113. 113 1s are 113. 113 1s are 113. Similarly, in denominators, 1 and 113 are the denominators. Correct? And again the LCM is 113. 113 1s are 113. 113 1s are 113. So 113 1s are 113 minus 64 divided by 113 whole divided by 113 minus 49 divided by 130. This 113 get cancelled. Am I right? So now 113 minus 64, 49. 113 minus 49, 64. 49 upon 64. Check in on 64 whether I am right or wrong. Correct? Interesting chapter, right? Or boring it is? Huh? No, it will not get bored. Interesting one. No doubt. सुरेश सर, बसवराज सर बाहर हैं। बसवराज सर का ಅಣ್ಣ ಮಾಡರ್ನ್ ಸರ್ ಹೇಳಿ ಬಸವರಾಜ್ ಸರ್ಕಾರಿ ಫೋನ್ ಮಾಡ್ತೀವಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಇದೆ ಒಂದು Glass is in there, man. Only just glass is in there. So thank you for asking this material. I think Amen. Thank you. Is finished? Can you take next example? Next, 8th one. Sorry, one more is there. Cot square theta. Both answer will be same. One answer and both answer will get the same. So in PUC we will learn that there is one more identity. Cot square theta is equal to 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. In PUC we will learn. Okay, so cot square theta is equal to cot theta is already given. Cot theta is 7 upon 8. It is given in the question. 7 upon 8 whole square. 7 upon 8 whole square. So 7 square is 49 and 8 square is 64. So cot square theta is equal to 49 upon 64. Got it? Yes. Now 8th question. Hello. Last time it's around. So 8th one. Question number 8. If 3 times cot A is equal to 4, 3 times cot A is equal to 4, check whether 1 minus tan square A divided by 1 plus tan square A, 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A or not, is equal to cos square A minus sin square A or not is the question. Okay? Yeah. See, what is given here? Cot is given. Cot A is equal to 4 upon 3. Cot A is equal to 4 upon 3. With the help of this function, easily we can write tan. But we don't know cos and sin. We don't know cos and sin. Again, we have to apply Pythagoras theorem here. So, draw right angle triangle ABC, and here angle A, formed theta, at angle it formed theta. Okay. How you define cot? Cot is equal to adjacent upon opposite. So 3 upon 4, adjacent upon opposite. So now a square of hypotenuse is equal to sum of squares of other two sides, AB square plus BC square. So AC square is equal to AB 4 square, BC 3 square. 16 plus 9 is equal to 25. So AC is equal to 5. AC is equal to 5. So now we can check whether LHS is equal to RHS or not. So first we can take LHS side, left hand side, LHS 1 minus tan. Tan means reciprocal of cot, 3 upon 4. 1 minus 3 upon 4 whole square divided by 1 plus 3 upon 4 whole square. So 1 minus, simplify this one. 3 square is 9, 4 square 16. 1 plus 3 square 9, 4 square 16. So here is 1 and here is 1. So LCM in numerator denominator is also 16 and LCM in denominator is also 16. So 1 16s are 16 1s are 1 16s are 16 1s are is equal to 16 1s are 16 minus 9 1s are 9 divided by 16, then whole divided by 16 plus 9 divided by 16. 16 get cancelled. 16 minus 9 7. 7 plus 9 is 16. Correct? Then divided by 16 plus 9 25. So LHS side is 7 upon 25. Now we can check RHS. RHS side. Right hand side. Cos. How you define cos? Cos is equal to adjacent upon hypotenuse. Cos square A. Cos square A minus sin square A. Adjacent upon hypotenuse square minus sin square. Opposite upon hypotenuse. Opposite upon hypotenuse.
Cot is equal to
Cot A is equal to
AB upon BC.
cot A is equal to 4 upon 3.
Adjacent upon
Adjacent 4 upon 3 actually. I took here 3 upon 4. Make it 10. You can solve with cot. Make it 10. Tan A is equal to 4 upon 3. Change here. Don't take it cot A. Tan can make. Tan A is equal to 4 upon 3. Tan A is equal to 4 upon 3. Cot A you can solve. Okay. So 3 upon 5. Sin is opposite upon hypotenuse. 4 upon 5. 4 upon 5 whole square. So 3 square 9 upon 25 minus 16 upon 25. So 9 minus 16. LCM is 25. 9 minus 16. 7. 7 minus 7 upon 25. But here it is plus 7 upon 25. If you take cot, you will get the right answer. If you take cot, you will get LHS is equal to RHS. But here I took tan, no? So that's what it came minus the negative. Okay. With the tan you can cot you can try. This is tan. Instead of tan you can take cot A. Then you can try in your home, not here. You will get the same answer, but you will not get negative here. You will get positive. Okay. LHS is equal to RHS. Note down. With the tan you can note down, not cot. Tan it is. It's almost to this alone. Can I end the session? 10 minutes break you can take. So next Kannada sir will continue.